That's a piecewise defined function. You might not have known it was a piecewise defined function, but it is. I'm now going to write it in different notation. And the notation I'm going to use is piecewise defined function notation. Same function, just written a different way. Watch carefully. Watch as the magic unfolds. Sometimes we call this bracket notation. Can you see why we might call it bracket notation? Okay. Not so much a matrix. A matrix is going to be an array of numbers with the straight brackets, and it's a way of organizing several values. Here I'm trying to actually define a function with two different rules. And you can have as many rules as you want, but this function has two rules. F of x is equal to, and I actually think it's more helpful to read when the rule is in effect first. So that's this part. This is when. Well, when x is less than 0, the rule is negative x. When x is greater than or equal to 0, the rule is x. So this is the rule, and this is when that rule is in effect. And if you think about it, right, I think you know what the function f of x equals negative x is, and what f of x equals x is. Let's see, maybe I will try doing some colors here. F of x equals x is this part of the function. Does that look like a linear function? F of x equals x, slope 1, intercept 0. I will then use red. F of x equals negative x. That's this part. Slope negative 1, intercept 0. That doesn't really look that colorful in there, does it? Sorry. It looks more colorful on my screen. But at any rate, do you see that? Okay, I want to show you how to use your calculator, and then we're going to do a bunch of examples. Do you see why this is going to make you cry a little bit? Come on, say yes. Come on, it's new notation. You've never done it before. It's sort of a little bit confusing. Come on, just give me a little bit. Tell me it's going to be hard. Thank you. That's what I'm looking for. I like your enthusiasm. Okay. So, you know that we could certainly do, what is it? Math, number, absolute value of x. You know that, right? Do you know that? Or sorry, I shouldn't say that. Did you know that you could go to math, number, absolute value, and do the absolute value of x function? Oh, great. Okay. See, I'm totally clueless. All right, you could do it this way. And if we graph that, and I'm going to go to Zoom, I think 4, Zoom decimal. You can go to Zoom standard if you want. We get exactly what Chelsea told us we were going to get. Is that okay? Say yes. Okay. But that's not what we really asked you to do. Sorry. No, that's not really what I wanted to say. That's not what I told you I was going to do. I was going to show you how we could actually use piecewise defined notation to do this same function. So I'm going to go back and I'm going to clear out y1. And what I'm going to do is I'm going to say, all right, the function is x. Now, I'm sort of gratuitously using parentheses. I don't need to, but it's a good habit when we're doing piecewise defined functions to put the function in parentheses. And then I'm going to show you how to say it's equal to x. When is it equal to x? Watch. Parenthesis, x, and I think it would make my day if I did. And if I didn't, that's okay. But I think I'm about to show you a button you've never seen before, or a character you've never seen before. Second, math, which is the test catalog. And I'm going to go down for when x is greater than or equal to, whoops, I passed it by a long shot, which is 4. And I'm going to hit enter, and I'm going to hit end parenthesis, whoops, and I'm going to hit 0, end parenthesis. So basically I'm telling the calculator, the function's equal to x when x is greater than or equal to 0. Questions about keys? All right. Guess what? The function is going to be equal to negative x, not minus x, negative x. Make sure you use the button below the 3. When x, I'm going to show you a key that you've only seen once before in your life. Second math. And now I'm going to go down to 5. And you can actually just type in 5 if you choose. When x is less than 0. And now go to my graph. Hey, check that out. How cool is that? That's the absolute value function. But we did it on our calculator using a piecewise defined function. Just like back here, we used absolute value and a piecewise defined function. Isn't that cool? Say yes. Yes. Okay, that's pretty good. I have to admit, if I had to give out stars for like enthusiasm, call and response things, Stephen Petra, you would get like the bulk of the stars. That was great. That was absolutely great. My morning is made. We should just pack up. Like, we should just call it a day. Like, we've ended on a high note. This is fantastic. Oh gosh, I don't know how to top that. Get out your classwork. Oh, I love you guys. It was great. It was totally great. Like, if it was any less corny, it wouldn't have been funny at all. But it was so corny that, like, it was hilarious. I love it. Gosh. I can already tell I'm totally going to miss you guys next year. Like, I'm serious. I already know that. All right. I got to catch up. I think I'm catching up. It's because you're chewing gum. Ditch your let's see. Oh, great. 10 looks like a really good one to do. We can sort of do it together as a class, orally. All right. We have that function that's defined for us as a piecewise defined function. It has all these different rules for all these different intervals. All right. Got to fill in the blanks. A. All right. We need f of negative 1. Adrian, which rule are we going to use for f of negative 1? X minus 5, 1, or x plus 1? No. No. Definitely. That was really good. That was excellent. Well done. So, f of negative 1 is the input. And if the input is less than or equal to 3, we use the rule x minus 5. You see how we read that? All right, so Adrian, finish it off. F of negative 1, we want to use the rule x minus 5, or input minus 5. So what will the output be when x is equal to negative 1? Perfect. Questions for Adrian on that? Is that all right? All right, Adrian, call on someone for f of 3 to tell us which rule we're going to use and what the output's going to be.
X minus 5.
Yep, you're still going to use x minus 5 because?
3, and it can be equal to 3.
Exactly. Very good. All right. And then tell us, using the rule, what the output's going to be.
Negative 2.
I love it. Great. Gabby, call on someone for f of 3.1. Which rule are we going to use, and what's the answer going to be?
1, and we're going to do the 1 for 1, and let's see, it would be, should it just be 1?
Definitely. That rule says if x is between 3 and 5, if that's the input, guess what the output's going to be?
Okay.
1.
And it's just giving you the y, the vertical intercept.
The 3 and the 5 are actually the... Is that what you're talking about?
No.
Nope.
Just giving you the 1, because there's no x.
Oh, yeah, fine. In this case, it's not a linear function, so we can't necessarily call it an intercept. But the rule is, you're right, it's just 1. That's what the rule is going to be. All right, I can finally catch up with you guys here. And I think you told me so far... this was going to be -6. I think Adrian told us that. This was going to be -2. Gabby told us that. Steve tells us this is going to be 1. Steve, calling someone for f of 4.9.
The x plus 1, x is greater than or equal to 5.
X is greater than or equal to 5. Is 4.9 greater than or equal to 5?
No, you add the 1 and then you
Mm-mm. You look at what the input... Yep. You look at what the input is, and if that input falls between, in this case, 3 and 5, this is the rule. So go ahead, finish that off. What's the rule?
So then
Or what? Exactly. Good. All right. Laura, calling someone for f of 5. Which rule we're going to use?
We're going to use x plus 1.
Okay, so now we use that one because 5 is... x is greater than or equal to 5, so that's our input. Okay.
Your output would be 6.
Perfect. Love it. The rule's x plus 1. Good. Calling someone for the last one?
Yeah.
you use x plus 1, so it's 8.
Great. Okay. Let's try to graph this, and let's try to graph it without our calculator. I know I showed you how to do it with your calculator. Let's see what we can do without it. And I'm going to, go here, grab a new piece of paper, and grab that function. And I'm going to do a nice big graph. I'm not going to try to cram it all in, like, one corner of my paper. Like, if I was doing this for homework, it would be nice and large. Why do I have mostly the first quadrant, or why do I mostly have positive x values here? Like, why is my graph skewed a little bit? I did that on purpose. I'm looking over here, right? And most of the actions happening between 3 and 5. 1, 2, 3, 4, 5, 6. All right. I will do this rule. Let's see. I will do this rule. Between 3 and 5, the function is equal to 1. Oh, I guess I should. Between 3 and 5. How's that? Does that describe what the output's going to be between 3 and 5? Sam, why do I use open circles?
Because it's not equal to 3.
Perfect. Great. All right. What's my rule going to be for when x is less than or equal to 3? Let's get green to do that. What do we have for the rule? Janelle, what's the rule going to be when x is less than or equal to 3?
When x is less than -3,
Say again? X minus 5. Perfect. So I need to draw the line x minus 5. X minus 5 has a slope of 1 and a y-intercept of -5. 1, 2, 3, 4, 5. So it has a y-intercept of 5, and it goes up 1, over 1, up 1, over 1, up 1, over 1. So it's going to look something like this. I know that's a little ugly, and I apologize. Dan, question?
How do you know slopes lower than 1?
It's hidden. The coefficient's 1. I'm looking at mx plus b, and it's like in disguise. How's that? Is that okay? All right, Tali. Oh, go ahead. Say.
For -1. Or
So the green. Sorry, ask your question again. I don't think I'm answering it.
that's just for the value -1 at one end of the graph. Like, what are you doing that for?
This is for all values when x is less than -3, is less than or equal to 3. So you can almost think about like I'm splitting this graph up into zones.
Okay.
Okay, so I have like a blue zone. I have a green zone, and I'm about to get my red zone. And that's going to be all the way over here. Tali, what's my rule for my red zone? X plus 1, all right? When it's greater than or equal to 5, right? So x plus 1, now this is hard. X plus 1 has a y-intercept of 1, and it goes up 1 over 1, up 1 over 1. So when x is equal to 5, what's the function equal to? When x is 5, the function's equal to 6. 1, 2, 3, 4, 5, 6. So that's all the way up here. And then my function's going to go have a slope of 1 from there. So it's going to look something like that. And that's my red zone. Do you see how each piece has a different definition based on what the function says? I think it's hard. I'd like to do another one, but I'd love to have questions. Tali and then Gabby. Can you scream because I can? Go, you don't have to scream anymore. Go ahead.
Would you start the x one at 1 or?
So x plus 1. So when x is greater than or equal to 5. So it's hard. Like here's the thing. If you were to draw this back, right? If it were to extend back beyond the red zone, it would totally have a y-intercept of 1. But it doesn't because it's starting at 5. Is that okay? Gabby, then Chelsea. Chelsea. Tell me what it's equal to. X what plus? Okay, x minus 5.
When x is less than or equal to 3.
Alright, so I'm going to have x. Hold on, I got to catch up. Less than, that's 6, right? Less than or equal to 3. Alright, now, here I have 1. Now, this one's tricky. If you want to do it on your calculator, you have to do x is... Alright, I'll do less than. You can't. Because your calculator doesn't understand it. So you have to do x is greater than 3 and x at the same time is less than 5. So that's the notation to show your calculator like between an interval. And then finally, x plus 1 for x greater than or equal to 5. And let's see what that graph looks like. Oh, how about Zoom Standard? Hey, what do you know? Not bad, huh? Not bad, I tell you. Another question. Steven! How do I get what lines?
How did you know where to put those? I know how you got the first one, like the very short one, but how did you get the other two? How did you know where to put them?
I'm totally sorry, I don't understand the question. I'm feeling slightly thick. Can you rephrase it in a different question? So,
I don't know.
are we talking about this calculator notation? I mean, I'm basically copying it from... Okay.
No, just like how we found it when you were writing it out. Like, how did you find... I mean, I don't know. It's a simple question.
Thanks. How could you be so dumb? I'm trying.
Okay, maybe, like, what are those two lines? Like, what does that represent?
He doesn't get why you put, like, how do you know where to put
How do you know where to put your
Like, I know
line?
you're splitting it into zones, but, like,
Okay, so...
on what basis are you doing it?
The green zone, the rule is whenever x is less than or equal to 3.
Right.
Well, here's everything over here.
Oh,
X is less than or equal to 3.
and then how do you, like, have it be a slope? I know that it's less.
The rule is x minus 5.
Oh, okay.
So this line is the line x minus 5
Okay.
in this zone.
Okay.
So in other words, if I were to graph the line x equal... I can't do it. If I were to graph the line x minus 5, that's what it would look like. But instead of graphing the whole line, just graph it in this zone.
Okay.
Just like the function f of x equals 1, that's the line that goes like this.
Yeah.
But don't graph it for everything, just graph it here. And then finally, x plus 1, right? That would look like this line.
Okay.
But I don't want the whole line. I only want it when x is greater than 5, so just graph it here. Does that help?
Yeah.
Sorry. All right.
It's kind of hard to visualize. I don't know.
Oh, it's really hard. I think it's going to make you cry. I'm totally serious. So you'll come in, and I would highly encourage you to do some by hand and check with your calculator. The rules aren't going to be hard. The rules are basically like linear functions, constant functions, maybe a quadratic function. You should do it by hand. Check in the back of the book or check with your calculator. Come in tomorrow. We'll talk through it, right? And then we're going to do more on this tomorrow because it's hard, okay? I will be honest. I think this is the first really hard thing we've done. I'm not saying we haven't done like medium things or medium hard things. I think this is hard, so it's going to take a little bit of time. All right? Hang out, wait for the bell. Have an absolutely terrific Tuesday.
Can I you put in yours into mine?